Today we're going to look at the depth-first graph traversal concept, which you'll see in A-level computer science. Now we're going to look at how to move through a graph and its nodes using the depth-first concept. So you can see here I have a graph, and if you look at the graph very carefully, we do not have at this point anything on our arcs. So each one of these sections here, that is a node, or you may know them as a vertice or a vertex. So a vertex being singular, or vertices allowing us having a whole graph. And then you have your arcs and your lines. Okay, so moving over to our actual traversal, if we want to move through our tree, so we're going to start at node A. So let's remind ourselves where we're starting from. So our starting node is A, and we want to move all the way through the graph. So we want to know in which order would we visit each of the nodes if we started from A, and we wanted to visit all of them. And in this case, what we would use is a stack. Now remember, a stack is one of our data structures, and it is a LIFO data structure. That means last in, first out. So we're going to put things onto the stack, push them onto the stack in fact, and then pop them off. So we're starting at A, which means that we place A onto the stack, and that means that we have visited A. And if we visited something, we are going to put a little asterisk in here to show that we visited it. But you'll also see over this side. Okay, so if we have visited A, we then look at the next possible node. So you can see here we can go to D, we can go to B, and we can also go to C. So what we're going to do is we're going to look at them alphabetically. So the lowest alphabetically from A is going to be B. So the next one in our visited is B, and then we place B onto the stack, which means that we're now over here. So we visited B. Now B, if we look at all the nodes that are attached, we have A, D, and F. Now, of course, the lowest one is A, but we've already visited it. So we're going to go to the next node, which is the lowest alphabetically, which is D. Now that allows us to place D onto the stack and say that we have visited it. Now from D, we have A, B, and E. But we visited A and B, so therefore the next one that we want to go to is E. So we follow down here, and E goes onto the stack and onto our visited list. Now E allows us to go to D and G, but D has been visited, so we're going to come across here to G. So G goes onto the stack, and we have visited it. Now at this point there's nowhere to go apart from backwards to the previously visited nodes. So because G is essentially, it is like a dead end, if you imagine, we want to pop it. So therefore we are going to pop it from the stack, which means that we have now gone back from G and backtracked, and that's a key term that you may want to be aware of. We are backtracking to E. Now E cannot go to any unvisited nodes, so therefore we are going to pop it from the stack up here, and then we are going to backtrack to D. Now D technically could backtrack to A and B, so we need to know where to go next. So if we look on our stack, we can go, well, if we pop D from the stack, the next place to go is to B. So therefore, we are going to backtrack by popping from the stack over to B. Now B has A, which it cannot visit because it's already been visited, but it does have an unvisited node of F. So that is our next one to visit. That goes on our visited list, and F goes onto the stack. Now F does have an unvisited node, so therefore we are going to go over here to C, which means that C can go onto the stack, and then we have visited it. Now technically from a human perspective, we can see that everything is now in the visited list. However, what we need to do is we still need to use our stack. So C has no unvisited nodes, so we pop it. We backtrack, so let's use a slightly different colour so we can see that we're backtracking again, to F. F has no unvisited nodes, so we pop it. And then we backtrack to B. So there we go, backtrack to B. And then B has no unvisited nodes, so we're going to go back to A. Now A is our starting node, and A has also no unvisited nodes. So once we have popped everything from the stack, that means that we have visited absolutely everything within our depth first graph traversal.